Okay, we'll start with the exercise. Okay, keep your textbooks. So we will start doing the exercise problems. Actually, exercise problems are a little bit tricky. So we will do this problems now. Exercise. First question. Page number. What is the page number? This 221, I think. See. Open the textbooks. First question. Okay. Textbook. This one. Science textbook. First question. Exercise problems. Okay. A piece of wire. Write down a piece of wire of resistance R. We'll not write the question, answers we will do. Okay. R is cut into 5 equal parts. These parts are connected in parallel. If equivalent resistance of this combination is R dash, then find the ratio of R by R dash. Okay. R by R dash. So, one resistor is there. Okay, one resistor is there. That is R ohms. Listen here. One resistor is there. That is R ohms. He will cut that into 5 equal parts. He will cut this resistor into 5 equal parts and he will connect them in the parallel. Okay. So first find what is the resistance when he connect everything in the parallel. Okay. So let us say this length of this resistor be L. Okay. Length equals to L. So when he cut into 5 equal parts, see, you can write this wire also like this, resistance is R. So I will cut this into 5 equal parts. Okay. So length is L. I will cut this into 5 equal parts. So each one will have length of L by 5. Okay. So length of each new resistor is L by 5. Okay. All other parameters are same. Area of cross section is same. Then the material is same. Rho and A is same. L will become L by 5. Okay. So what will be the resistance? Now R is equal to rho into L by A. Okay. Now I will make this L by 5. 5 resistors will be there. So what will be that resistance? New resistance. Okay, if I take it as R1, that is equal to rho into L by 5 by A. That is R by 5. If you cut that, okay, because rho will not change, area of cross section will not change. So if you cut that into 5 parts, each resistor length will become L by 5. So the resistance of the new resistor will be R by 5. So like that, 5 resistors are there. Now I will connect them in the parallel. He has asked to connect them in the parallel. This 5 are there. 2, 3, 4 and 5. Okay. Each one is R by 5 now. So what will be equivalent resistance? That is equal to 1 by R by 5 plus 1 by R by 5. Like that 5 is there. So what you will get? 5 by R plus 5 by R, 5 by R plus 5 by R plus 5 by. Okay. So this is equal to R is common. Add everything, will get 25 by R. Is equal to 1 by R equivalent. R equivalent is equal to R by 25. So this is the resistance. Okay. See again I repeat. There is one resistor whose resistance is R ohms. Okay. He will tell them its length we will take it as L. Okay. That he will divide into 5 resistors. So each length will become, now each resistor length will become L by 5. Like that, now you have 5 resistors. All these you will connect in parallel like this. Okay, you have to find equivalent resistance of that. Now, each resistor value will become how much? Length I have made L by 5, but row and area of cross section I have kept as it is. So, now the new resistor value will be whatever R was there divided by 5. This will be the resistance of new resistor. So, like that, you have 5 resistors which are connected in parallel. Now, okay, you told parallel only, no? They are connected in parallel. Now, we know that what is the parallel resistor formula? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 until 1 by R5. So, each resistor value is R by 5. When it goes up, 1 by R by 5 will become 5 by R. Like that, 5 is there. So, same denominator, add all the numerator, 25 by R. Or R equivalent is equal to R by 25 ohms. Okay, right. Now he is asking the ratio of R by R dash. So this R equivalent he is calling as R dash. Okay, R dash is equal to R by 25. Now you have to find ratio of R by R dash. Mark this problem as important. Okay. So we know R dash is equal to R by 25, which we got the equivalent resistance. And he is asking the ratio of R by R dash. So it is equal to R divided by R by 25. Listen this. This is the denominator. Sorry, wait 1 second. R by R dash. So R by R dash is asking. So this portion is the denominator. When it goes up, it will be 25 by R. So this is 25. Is the answer. Ratio is 25. Don't take R by R and then the reciprocal of 1 by 20. See here, R by 25 is the denominator. Take the reciprocal of that. Okay. Next question. Which of the following terms do not represent electric power in a circuit? Check. So what are the formula for electric power? Tami, what is the power formula? P is equal to? Sunaina, what is the formula for power? Last class only we studied E by T. What is E? E where we use
W by V plus power I into I.
B into I. B into I. Okay. Then instead of B, I can write, P is equal to V into I. This is one formula. V into, instead of I can write V by R. There I will get V square by R. Another one, P is equal to, instead of V, I can write I into R. So that is I square R. 3 formulas are there. So which one is not the formula for the power? Compare and tell me.
I square.
So option B. Okay. Why you people have not started reading? Sunaina, what happened?
It's a lot of projects. We are doing a lot of projects. Friday we have to study schools.
Saturday, Sunday you can study, no?
But even Saturday Sunday we have practice.
1 hour you revise. You have to revise. Otherwise you will forget. Okay. Third one, an electric bulb is rated 220 volts and 100 watts. When it is operated on 100 volts, the power consumed will be. This is the question. Okay. So what is given? Electric bulb is rated, voltage is equal to 220 volts and 100 watts. So power is 100 watts. So when it is operated on 110 volts, what is the power consumed by it? This is the question. Okay. So when they are telling 220 volts, it is rated 100 watts. That means when voltage it is applied for the bulb is 220 volts, it will take power of 100 watts. That is the meaning. Okay. So when they apply the voltage of 220 volts, power it consumes is 100 watts. Okay. Now, in any setup, see, this is important. Any setup, the resistance will be the same. I told, see, voltage increases, current also increases correspondingly, then resistance will be same. Voltage decreases, current also decreases, correspondingly, resistance does not change. So, if any given setup, resistance will not change. Only when the length of the wire changes, or bulb you will change, then the resistance will change. Here in the whole setup, they are changing the voltage, but they are not changing any setup of that. So the resistance will be constant here for the given thing. Okay, you change, you vary voltage or current, the resistance will be constant. So first try to find the resistance of this bulb. Okay. What we have, power, I can write it as V square by R. R is equal to V square by P. So how much you will get here? V square is 220 into 220 divided by 100. How much? 22 into 22. How much you will get? It is 484 ohms. Okay, it is 484 volts. Now, if they give the voltage of 220 volts, 110 volts, now he will decrease the voltage to 110 volts. So, what will be the power consumed now? So, I can use the same formula. I know the voltage and I know resistance will not change for the given setup. So, power is equal to, I have to use V square by R. Calculate and tell me how much you will get. See, if voltage increases, current increases. If voltage reduces, current decreases. So you will not know. By using current formula, you cannot find. But resistance will be constant for the circuit. So I can use V square by R to find the value. That means why you have not started reading? Saturday, Sunday, what you will be doing? Huh? Whatever is there, half an hour, 1 hour, you people can't study. Sit once you revise everything, once you by heart formulas, that much you can do, no? Otherwise, you will forget what we have done. And that will be there for a test also, periodic test and all. It will help for that also, right? Then you are getting?
Yeah.
Okay. 25 watts, correct. 110 into 110 by R. R is equal to 484 ohms. So we will get 25 watts. Two conducting wires of same material and of equal length and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combination will be. This is a question. So they will take two wires. Okay. They will consider two wires which has same length, same row, and also same diameter. So area of cross section is also same. So that means what? Resistance of the two wire is also same. Okay, he's telling two conducting wires, same material, same length, and same diameter. So, if both are identical, length, same material, area of cross section, they will have the same resistance. Now, first they are connected in series. So, when they are connected in series with some potential difference, okay, we'll call this as V. So this is R and this is R. Okay, this is a series circuit. And now they both are connected in parallel. In the other circuit, they were connected in parallel. Like this. And they are also connected between the same potential difference. V here. Okay. So he is asking, what is the heat produced? The ratio of heat produced in series and parallel. Okay, so in this series circuit, equivalent resistance is 2R and it is for the same potential difference V. What about here? Equivalent resistance will be R by 2. Will be equal to, so R equivalent here will be R by 2. Okay, so another circuit which is in parallel here, now resistance becomes R by 2, and for this also the potential difference is same. He has given it as same, so it is V. Okay, now what is the heat produced in both? Try first you for series HS you write. What is the heat produced here? Heat is I square into R into T. Or instead of that, can you use voltage and try, because we don't know current here. I square into R into T. Instead of I square, I into I, right? I can write it as V by R into V by R. So V by R into V by R into R into T. So you will get V square into R. This is the one. Understood or not? See, we have heat produced is equal to I square into R into T. I don't know, but V is same for both. I want to use voltage. So what I will do, instead of I can write it as V by R, Ohm's law. So V by R into V by R. That is V by R into V by R into R into T. So this is V square by R into T. Okay. Heat produced by series. What about parallel? Here, I square, I can write it as V by R into V by R. Here it is R by 2 is the equivalent resistance. Into R by 2 into T. So, parallel, I can write it as 2V by R into 2V by R into R by 2 into T. 2V square T by R into T. Two R, no, sorry. We'll get to Understood or not, Aditya? Didn't understand. Okay. So there is, see, one resistor is there whose length L rho and area of cross section. Okay, there are two resistors. They are of having same length, same row, same area. So resistance will be same for both the resistors. Okay. First, I will connect them in series. I don't know the value. I'll take it as R. Okay, so two resistors have connected in series and they have a potential difference of V. This is the first circuit. So what is the equivalent resistance here? 2R and voltage is V. Next, I will take another circuit where the same two resistors are connected in parallel with the same potential difference V. Okay, so two resistors are in parallel. What will be its equivalent value? It is R by 2 and with the same potential difference V. So these are the two setup what he has told. Now he is asking what is the ratio of heat produced in the series circuit by the heat produced in the parallel circuit. So you have to find heat produced in the series circuit then by parallel circuit separately. Okay. So what is the formula for heat? I square into R into T. Correct. So I don't know. In the circuit, I know resistance, I know voltage. So instead of I will take it by Ohm's law. I can take it as V by R. Okay. So instead of I can take it as V by R. Now, here, what is I? Voltage I have given V. Resistance 2 by R. It's this from this circuit, correct? So V by 2R into another I, same thing, V by 2R into. Now the resistance for this circuit is 2R into time taken T. So if I simplify, I will get V square into T by 2R. This is for the heat produced by the series circuit. Next, in the parallel circuit, I have voltage is V. Resistance of this circuit is R by 2. Put this, then this is I square, this is R into T. Simplify, you will get 2V square into T by R. Now I want the ratio. Okay, now I want the ratio of series by parallel. Now substitute the values. Okay. Shall I clear this? Then series, I have V square into T by 2R. Okay, parallel, I got 2V square into T by R. I want to find heat produced by series circuit by heat produced by parallel circuit. So V square into T by 2R. Whole thing divided by 2V square into T by R. This is the denominator. Take the reciprocal. V square into T by 2R into R by 2V square into T. So that is equal to 1 by 4. Hs by Hp is equal to 1 by 4. That is Hs is to Hp is equal to 1 is to 4. It is equal to 1 is to 4. How is the voltmeter connected in the circuit to measure the potential difference between the 2 points? Okay, write down this. A voltmeter is always connected in parallel. It is always connected in parallel in the circuit to measure the potential difference. To measure the potential difference. Okay. Always remember, voltmeter is always connected in parallel to measure the voltage, whereas ammeter is always connected in series to measure the current. Okay. Again, I repeat, voltmeter is always connected in parallel, okay, to find the potential difference, whereas ammeter is always connected in series to measure the current. For example, this is one circuit is there like this. Okay. Now this is R1, R2. I want to measure the voltage across this R1 point across A and B. I want to measure the voltage. So what I will do, I will put the voltmeter like this in parallel. Wherever I want to find the voltage, there I will put the parallel. So this is plus, right? So this point will be plus. Here it is minus. So this will be minus. If I want across R1, I will measure here. If I want across R2, I will put the voltmeter here. So wherever I want to measure, okay, there I will put the voltmeter. Across that is parallel, I will put the voltmeter. Okay. Ammeter, it should be always connected in series to find the current. Voltmeter to measure voltage, ammeter to measure the current. The value of current flowing the given resistor for the corresponding value of potential difference V across the resistors are given below. See here, they have given current and voltage. So current it is 0.5, voltage it is 1.6. Current in ampere, voltage in volts they are given. Okay. Then current is 1 amps, voltage is 3.4. Then comes to 6.7, 3, 10.2. 4, it is 13.2. So you have to plot current versus voltage. You have to plot current versus voltage. So what you have to do is plot that now. So always take the current here. Take current in the x-axis, I in ampere. Okay, voltage V in volts. Now plot that. Plot the graph. Current versus voltage. Now you do it every time. To find resistance, it will be easier for us. Okay. Do it. Plot now. So 0.5, 1, 2, 3, 4 is there. I can take 1 unit is 1 centimeter is equal to 1 unit. 1, 2, 3, 4, 5. What about voltage? Until 13.2 I need. You can take 2, 4, 6, 8, 10, 12, 14. So 0.5 amps, voltage is 1.6. 0.5. Voltage between 0 and 2, it's a 1. In between, you have to take 1.6. Then 1 and 3.4. Then mark 2 and 6.7. 2, 6.7. Three 10.2. Four 13.2. Okay. See, slope is equal to y-intercept minus the x-intercept. So it will be easier. That's why we are actually you can do the other way also. Okay. See here, I have taken in amps, V in voltage. Okay. Try to plot I versus V. I have taken in x-axis. V I have taken in the y-axis. Okay. So since I 0.5, 1, 2, 3, 4 is there. So for 1 centimeter block I have taken, it says 1 unit. Here 1 centimeter I have taken as 2 units. Okay. Now try to plot that. If you observe here, it is a straight line. For a conductor, you will get a straight line. For a conductor, you will get a straight line. Okay. Now, slope will be what? The y-intercept minus the x-intercept. That is, take 2 points. What is the delta y here? Delta y. I have taken between 1 and 2. Delta x is 2 minus 1. That is 1. Delta y will be the 6.7 minus 3.4. So you will get it as 3.3. So resistance of this circuit or the wire is 3.3 volts. Okay. And since it's a conductor, between any 2 points you take, almost the same value will get. Last ninth one. A battery of 9 volts is connected in series with the resistors 0.2, 0.3, 0.4, 0.5 and 12 ohms respectively.
Power line and message is people.
1. Oh. How much current would flow through the 12 ohm resistor? This is a correct question.
Add all of them.
Correct. 0.2. How many are there? 1, 2, 3, 4, 5 resistors are there. 3, 4, 5. Then you have the voltage. Okay. This is 9 ohms. So here resistor 0.2 ohms. This is 0.3 ohms, 0.4 ohms, 0.5 ohms, and this is 12 ohms. Okay. So how much current would flow through the 12 ohm resistor? Listen here. Current from the positive terminal, it comes to the negative terminal. So this current will, since it's a series circuit, all the current will flow. Whatever current is there, it will flow through all the resistors here. Correct? There is no other path to flow. That is why the same current will flow through all the resistors. So now 12 ohm resistor, what is the current? So find the equivalent resistance, then find the current. Total current will be equal to total voltage by R equivalent. Okay. So voltage, it is 9 volts, find R equivalent. R equivalent is what? How much you will get? 13 point. Okay. 3 plus 4, 5. So it is 13.4 ohms. So current is equal to 9 by 13.4. So it is 0.67. Okay. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.